Hello again and welcome back. In the previous class, we have already talked about pure substances and mixtures. We know that pure substances are substances which are made up of only one particle, and mixtures are those substances made of two or more matter. We also know that there are two types of mixtures. They are homogeneous and heterogeneous mixtures. We know that homogeneous mixtures are those mixtures which have a uniform composition throughout, and they don't have a clear visible boundaries, and we cannot tell them apart from one another. For example, sugar dissolved in water. And heterogeneous mixtures are those mixtures which have clear visible boundaries and we can tell them apart. And today we are going to talk about solution. A homogeneous mixture of two or more substances is called a solution. When we say a solution, it is still a homogeneous mixture. It is made up of different types of substances, but when they mix together, they mix thoroughly. They have a uniform composition. For example, here we have a sugar dissolved in water. When you dissolve sugar in water, you cannot tell them apart anymore. Even if you boil it or even if you shake it, you cannot tell them apart. And another example is tea. It is made from tea leaves and sugar and water, but they become one. These types of mixture are known as solution. A solution has a solvent and a solute as its component. When we say a solution, it is a homogeneous mixture. And this solution has two components. They are solvent and solute. First, we have solvent. Solvent, the component of a solution which dissolves the other component in it. That is the component present in large amount is called the solvent. When we say a solvent, it is the part of the solution which dissolves the other components. For example, when we dissolve sugar in water, we know that water is more or larger than sugar. Here we can say that water is the solvent and sugar is the solute. Solute, the component that is dissolved in the solvent, that is the component present in lesser quantity is called a solute. We know that in the previous example, we talked about sugar dissolving in water. From there, we can see that sugar is the solute and water is the solvent. Now let us see solute and solvent again. Solute, the component in solution that is present in lesser quantity. We know that from this example also, the solvent is present in larger quantity, while the solute is present in lesser quantity. Solvent, the component in solution that is present in greater quantity. Next slide. When we dissolve sugar in water, we get sugar solution. In this solution, sugar is the solute and water is the solvent. It is a solid in liquid solution. We know that sugar is a solid, while water is a liquid. Now we can say that it is a solid and liquid solution. Next, another example we have is aerated drinks. Aerated drinks like soda water, for example, Coca-Cola, Pepsi, and etc. These are made up of a gas and a liquid. The carbon dioxide gas acts as a solute and the water as a solvent. This carbon dioxide gas mixes with the liquid and they form the aerated drinks like soda water. And another example we have here is sugar dissolving in water, the same as before. Now let us see the properties of a solution. 1. A solution is a homogeneous mixture. We know that solution is a homogeneous mixture. That means it is made up of two or more substances, but they become one, or they are mixing thoroughly, or they have a uniform composition. 2. The particles of a solution are extremely small, less than 1 nanometer in diameter. So they cannot be seen by naked eye, even with a microscope. We know that these particles of a solution, they are very, very small. Even if we use microscope to look at it, we will not be able to see it in our naked eye. 3. Particles in a solution cannot scatter light passing throughout the solution. When light passes through a solution, suppose for example, let us say a sugar solution, that means sugar dissolving in a liquid. When we pass light through it, the light will not scatter. That is because the particles present in the solution is too small. For the solute particles cannot be separated from the mixture by filtration, nor they settle down when left undisturbed. For example, in a sugar solution, when you mix a sugar in a liquid, even if you keep it without disturbing it, you will not get back the sugar again. They remain as a sugar solution. Or even if you filter it by filtration process, you will not get the sugar back again. That is why because they are already mixed thoroughly. They have become a solution. A solution which can dissolve no more of the solute at a given temperature is called a saturated solution. For example, let us say that suppose you are trying to add a sugar in a water. First, you can add some amount of sugar in it. But if you continue on adding sugar again and again, there will come a time when you cannot add more sugar. Even if you add it, the sugar will not dissolve it anymore. That is, the solution has reached its saturated level. A solution which cannot dissolve no more of the solute at a given temperature is called as saturated solution. From careful experiment, it can be calculated that about 35 gram of common salt can be dissolved in 100 gram of water at room temperature. No more salt can be dissolved after this. Now, solubility. It is the amount of the solute present in 100 gram of the saturated solution at the given temperature. When we say solubility, it means the amount of solute present in 100 gram of the saturated solution at the given temperature. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. Suppose in a solution, or in a liquid, you can add sugar, but there will come a time when you can no more add sugar, when before it reaches its saturated level. If the amount of solute contained in a solution is less than the saturation level, that means if you add a sugar cube in a liquid and it still dissolves, that means it still doesn't reach its saturated level, and we call this type of solution as unsaturated solution. Now let us see the solubility of some substances in water at 30 degrees Celsius. Substance. First, we have common salt. Solubility in 1 gram of water is 36.3. That means you can add 36.3 gram of common salt in 1 gram of water. Next, we have sugar, 220, copper sulfate, 25, quicklime, 0.16. The amount of solute present in a given amount, mass or volume of a solution, or the amount of solute dissolved in a given mass or volume of solvent is termed the concentration of solution. When we say the concentration of solution, it means that the amount of solute present in a given amount. That means how many solute are present in a solution. That is, we can write the concentration of solution as concentration equal to amount of solute by amount of solvent. If you want to find the concentration of a solution, we can use this formula, or concentration equal to amount of solute by amount of solution. Concentration of a solution may be expressed in terms of mass by mass percentage or mass by volume percentage. We can express this concentration of solution in terms of mass also, or by volume percentage. The formula we have is, first, mass by percentage of a solution is equals to mass of solute by mass of solution into 100. 2, mass by volume percentage of a solution equals mass of solute by volume of solution into 100. Now let us see one example. A solution contains 40 gram of sodium chloride in 320 gram water. Calculate the concentration in terms of mass by mass percentage of the solution. Now let us do solution. Mass of solute sodium chloride 40 gram. That is, mass of solute means we are adding sodium chloride or common salt in 320 gram of water. Common salt or sodium chloride is the solute, and the solvent is water, that is 320 gram. Now to find the mass of solution, we need to add mass of solute plus mass of solvent. Mass of solute, we know that solute is common salt or sodium chloride, so 40 gram. And mass of solvent is water, that is 320 gram. If you add this, you will get 360 gram. Now again, let us try to find the mass percentage of solution. To find the mass percentage of solution, we use the formula mass of solute by mass of solution into 100. We already know that the mass of solute is 40 gram, and mass of solution is, we also know that it is 360 gram. And if you multiply it into 100, you will get 11.11% nearly. Now for your assignment, question number 1, define a solution. 2, what is a solvent? 3, write the properties of a solution. 4, define saturated and unsaturated solution. 5, a solution contains 10 gram of sodium chloride in 20 gram water. Kasi hili lai cha 2020 ga thi. 5. A solution contains 10 gram of sodium chloride in 220 gram water. Calculate the concentration in terms of mass by mass percentage of the solution. Thank you. That will be all for today. And I want all of you to do your assignment. And until we meet again, stay safe.